Hey guys, Mr. Yisley here. So we're on to lesson number 25 in chapter 4, all about writing linear functions. And in lesson number 25, we're going to put together these ideas of writing arithmetic sequences of terms and figuring out what they are based on the information they gave us about the arithmetic sequence. So we've got two examples here that we're going to go through. And the first example we have here, we're going to call that example A. I apologize, I forgot to change that. So example A, right? We're going to write an equation of the nth term of the arithmetic sequence, 14, 11, 8, and 5. Now people kind of get confused. What does nth term mean? It's just saying, hey, nth term is a term to be determined later, right? We'll figure out what it is later. But nth term just simply means A of n, the nth term, right? A of n. So when we're writing the nth term of something, it's always going to start with A of n, right? Because once we know the term's position, all right, in there, all right, we can plug that in and figure it out, all right? We can plug that information in and figure it out. All right, so then what we want to do here, all right, is we need to plug this information into that formula that we had above, which reminder of that formula was A of n equals A of 1 plus n minus 1 times d. So we're going to plug information in there. All right, well, A of 1 stands for the first term. Well, the first term of this arithmetic sequence is 14, so I'm going to write that. A equals 14, and then that is plus the parentheses n minus 1. Well, I don't know what n is. That's the nth term. So I'm going to leave that as n. So I'm going to call that n minus 1. All right. Parentheses d. So the common difference. Well, I need to figure out the common difference. So I got to go in there and do that. So 14, to move from the first term to the second term, I needed to go from 14 to 11. I had to subtract 3. From the second term to the third term, from 11 to 8, I had to subtract 3. And from the third term to the fourth term, to go from 8 to 5, I had to subtract 3. So the common difference was -3. So I'm going to plug that information in right here. And remember that that is multiplying. So I'm going to put it in parentheses, -3. So that is how we write the equation of the nth term of an arithmetic sequence that they gave us. All right? Now you may be saying, well, why do I need to write this equation of an nth term? Because when they give us information about a term and they say, hey, it's in the 50th position, we can simply take that, like they did right here, then find A of 50. We can take that 50 and replace both of the n's here, right? Which is what I talked about in the last video about replacing those n's. Right, so I'm going to take this 50 and replace the n's, and then I can solve it down to figure out what is the number of that term. So let's do that. So A of 50 is going to be equal to 14 plus, again, n is 50, minus 1 times the common difference of -3. So I've plugged all of that information in. Right? Once I've gotten there, all I need to do is simplify down the right side. So I've got to follow that idea of PEMDAS. Well, according to PEMDAS, I need to simplify inside parentheses first. So I need to simplify 50 minus 1. So if I keep going down, I get A of 50 equals 14 plus 50 minus 1 is 49 times -3. Well, then I need to follow, do I have any exponents? No. Do I have any multiplication or division? Yes, I do. I have a multiplication of 49 times -3. Well, if you plug that information in or do some quick math on your paper, you would find that that equals -147. So I need to simplify that. So I get A of 50 equals 14 plus -147. I could also write that as A minus, or excuse me, 14 minus 147. Either way is fine. Right? And then last part of PEMDAS says, hey, you need to simplify it down, any addition or subtraction. Well, I've got some addition, or you could call it subtraction, whichever you want. Right? So I'm going to say A of 50 is equal to 14 plus negative 147. Well, that's going to end with a negative number. And then 147 minus 14 is 133. So negative 133. So the 50th term, a of 50, is equal to negative 133. So again, I could have written that out. I could have gone from 5, subtracted 3 again, and gotten 2. From 2, subtracted 3 again, gotten negative 1, and done it over and over and over until I hit the 50th term, right? Which can take quite a while, right? But because I have this formula, I was able to simply plug that 50 into the formula and then simplify it down to figure out that the 50th term in this sequence is negative 133. All right, well, we've got a second example here. I'd encourage you to try this one on your own and then check your answer with me. So I'm going to call this example B. All right, and we're going to write the equation of the nth term of this arithmetic sequence. Right? Well, in order to write the equation of an arithmetic sequence, I need to have the first term. I've got that. But I also need to have the common difference. All right, so let's go ahead and figure that out first before we do anything else. So the common difference, to go from the first term to the second term, from 8 to 16, I have to add 8. To go from the second term to the third term, from 16 to 24, I have to add 8. And to go from 24 to 32, I had to add 8. Right, so the common difference was 8. So if I go to write the nth term, again, remember that means it's going to be a of n equal to, well, what is a of 1? Well, a of 1, my first term was 8. All right, very good. Plus parentheses, well, that would be n, and we don't know what n is, so we're going to leave it as n, minus 1. Parentheses times the difference, and the common difference was 8. So times 8. And I don't need to necessarily put that in parentheses because there's no negative sign. I know that the number next to a parentheses means multiplication. So there we go. We've got the information we need. An a of n. We've written the arithmetic or the equation for that arithmetic sequence. Now that tells me that I could go in and figure out any term in this arithmetic sequence. Just all I need to know is, what does n stand for? Well, they've told us that they want us to find it for a of 25. So n stands for 25. So let's plug that information in. A of 25, because n stands for 25, equals 8 plus, again, n is 25, minus 1 times 8. All right, well, again, got to follow that PEMDAS model, which says simplify inside parentheses first. So a of 25 equals 8 plus 25 minus 1 is 24, and then times 8. Well, next step would be exponents, don't have those. Third step, multiplication and division. I've got multiplication, so I need to multiply 24 times 8. And if we do that math really quickly, either in our head or on our paper, we find that 24 times 8 is 192. So a of 25 equals 8 plus 192. And then last thing I need to do to simplify this down is add 8 plus 192. So a of 25, so the 25th term, is equal to 200. So the 25th term is equal to 200. So again, I could have written all those numbers out till I had written the 25th term by adding 8 every time, so I would have gone from 32 to 40, 40 to 48, so on and so forth. Or I can plug them into the formula and figure them out through some quick order of operations and solving and simplifying down. All right, well, if you have any additional questions on how to write these equations for arithmetic sequences, please let me know. But otherwise, you should have what you need to continue on in the chapter.